Hi guys, today we're going to talk about the flow of energy throughout ecosystems. So yesterday we talked a little bit about ecosystems and their place in the grand scheme between biomes and populations and communities, and we talked about some of the interactions between the organisms in those ecosystems. Today we're going to talk a little bit, obviously has to do with the interactions. We're going to talk about how energy moves throughout the ecosystem. So we're going to be talking a lot about how organisms feed and get their energy, how they get their nutrients. So we're going to start at the bottom. I mean, basically, um, pretty much most life on the earth comes from the sun. Um, the reason that we say that is because even though there are lots of organisms that don't directly get their energy from the sun, they're going to get their energy from consuming another organism that somewhere down the food chain or the food web probably got their energy from the sun. And we call those bottom level the initial things that make their own nutrients and sort of serve the basis for the food web. We call those producers. Now, in most cases, of course, that's going to be from the sun, and we'll talk about that in a second. Producers are also what we call autotrophs. Auto means self, and so when we say that they're an autotroph, it means that they make their own food. And so, generally speaking, that's going to be photosynthetic plants, photosynthetic algae, and stuff like that. And that's usually how that's going to work. Now, we talked about photosynthesis earlier in the year. Remember that what's going on is that we've got sunlight. We're going to take CO2 in from the atmosphere. That's going to get converted into glucose, and then that glucose is sort of the energy source that almost every living organism uses. Even the plants that produce it, that's the reason they're producing it, is because it's their energy source for their cellular activity as well. But of course, what that allows is that if they make a surplus of that, if they make extra, then other organisms can consume them. Now, they don't all have to be photosynthetic organisms. There are a few organisms called chemotrophs. They're also autotrophs, meaning that they make their own food. But they make their own food from inorganic compounds instead of from sunlight. Typically speaking, these are bacteria, and they're found a lot maybe at the bottom of the ocean floor where there's these hydrothermal vents. There's going to be a lot of heat, so you got energy there. And then there's a lot of nutrients, usually in the form of sulfur-based compounds is what they're going to use. So they're a little different. But they play a very small role in our food web overall. So if it's an organism that doesn't make its own food source, we call it a consumer, or to use a slightly more technical word, we call it a heterotroph. All consumers depend on producers. So if all the producers died off, then eventually the consumers are going to die off because they're not going to have anything left to eat after a while either. Even if it's a complete carnivore, even if it's something that only eats meat, you think to yourself, well, if they only eat meat, then aren't they going to, be able to survive if the plants die because they don't eat plants? Well, plants are what the meat that the higher level consumers eat, so they're going to have a plant source also. Now, when we talk about consumers, when we talk about heterotrophs, there are a few categories. So at the bottom we have herbivores, which are primary consumers. Those are things that are going to eat the plants or the algae or the plankton or whatever, the phytoplankton. So those are, you've got primary consumers, which are herbivores, and they typically eat plants, okay? And so they're going to eat those first level producers. That's what they're going to eat. That's going to make up basically the entirety of their diet. We've got secondary consumers above those. Secondary consumers are those that eat the primary consumers, and then we've got tertiary consumers above that, and then we've got some things like apex predators and stuff that are at the very top. Your great whites, your birds of prey, tigers, lions, stuff like that, and to some degree humans. Now, we could split those consumers up into actually a couple of categories because even though the way we said that would make it sound like a secondary consumer would have to be a carnivore, carnivores are obviously things that eat other animals. But you can have a lot of high-level predators that are also omnivores, that they're going to eat plants and other animals. And one of the classic examples of that is a bear. They're happy to eat berries and stuff like that, but they'll also eat meat sources. Raccoons are another good example, and then of course humans are the best example of that because humans can get their sustenance from either way. They can get it from plant sources or from animal sources, and the vast majority of humans obviously get it a little bit from both. These organisms don't fit directly in the food web. We'll see when we get to cycling here in the next unit that they play an important role there, but there are some other organisms that don't strictly fit into the whole producer-consumer sort of deal. So we've got decomposers. They are consumers, but as they're getting nutrients from their food sources, they're actually going to produce nutrients as well. So they're an important part of the cycling of matter that we're going to talk about in the next section. And then we have what are called detritivores, and detritivores basically they're not consumers in the sense that they eat other organisms, but they only are going to feed on the waste or the dead bodies of other organisms. So that makes them a little bit different than sort of your typical consumers that we talk about. Now we can organize all of these into what we call trophic levels. Trophic levels are basically feeding levels depending on where you get your food. So if you're a producer, you get your food from the sun, or in the case of those chemotrophs, maybe from some geothermal vents or something. And then primary consumers, the herbivores, they're going to get their food from the producers. Secondary consumers are going to eat primary consumers. Tertiary consumers are going to eat secondary consumers. And this is where we get the idea back in elementary, middle school of a food chain, that at the bottom we've got producers and then primary consumers and secondary and tertiary and so on and so forth all the way up. In reality, the situation's a lot more complex than a food chain. What we usually talk about in most science classes are food webs, because there's complex interrelationships here. It's not like there's just one food source for the top level consumers, and it's not like some of those secondary consumers don't eat different levels. So like, you've got something like a tundra swan here that can both eat the bivalves and clams and stuff like that, but it's also going to eat some vegetation as well. So it's getting its food from multiple sources. And that's going to be true of a lot of different things. And then you can see that in the food web, you've got something like these, smaller fish that a lot of different kinds of birds are going to eat. And so if something happens to that smaller fish, that's going to create a big disruption in the food web. So just keep in mind that it's a lot more complicated than the simple food chain that we learned about in middle school. So I want to show you this because this leads us into something called an ecological pyramid. So if we look at the bottom, we got producers. Let's say that our producers have 10,000 units of energy. And so then we go up to the next level where our primary consumers are going to eat that food source. Okay, so let's say, just for example, that we've got phytoplankton. Those are the photosynthetic plankton in the ocean. And so then we've got the zooplankton, okay, the animal plankton. They're going to consume those phytoplankton. Now, what you'll notice here is that we've got an immediate large drop-off. We've gone down by 1/10, basically, to the next level of energy. So we had 10,000 energy at the producer level. We got 1,000 at the primary consumer level. We go up to the secondary consumer level. We go down to 1/10 of that level before it. And so we're only at 100 units. And then we go up to our top level here, say humans. So say we're eating the fish that ate the zooplankton, that ate the phytoplankton. And we're only actually getting 10 units of energy out of that original 10,000. The reason for that is that there's a lot of heat that's given off in each case as we go up from one trophic level to another. It's just sort of a rough rule of thumb to say that basically every trophic level you go up, you only get 10% of what you had before. And obviously, if you go back to our food web here, and maybe there were more than just 3 chains there, then you're getting a whole lot less as you go up. So if we went up another level above this, we'd be down to 1 out of the original 10,000. And so you're going to lose a lot of energy as you move further and further up the food chain. That's really important because that's one of those reasons why people will say that it would be a lot more efficient if as humans we didn't eat meat. If we just ate producers and we were the primary consumers, then we're obviously getting a lot more energy for that amount because we're not losing a step at each step in the trophic level. And this trophic level can be, these ecological pyramids and trophic levels can be used in a couple of ways. So we could use them in case of energy, which we just did. We could just talk about biomass because you're going to lose some mass in each step. We could just talk about numbers of organisms. So you've got to have thousands upon thousands, millions really, of producers to be able to support these top carnivores. So if you're talking about something like a tiger or something like that, there's very few tigers or lions because they lose energy at each level. And so therefore it's going to take millions of producers to support the herbivores that are then going to get consumed by these upper level carnivores. And so every step you go up, you're going to lose more. And so what that means is numbers wise, you have much fewer of your carnivores typically than you do of your producers. Okay? So hopefully that gave you some concept of how energy moves through an ecosystem. It moves from producers that basically create the energy in a chemical form that we can all use. And then as we go up each level, it's going to get reduced. A lot of it gets lost to heat. Okay, so hopefully that helps you out. In next section, we'll talk a little bit more about the actual systems matter-wise about how that gets converted out.